section.
Hello, my dear students. We're going to continue our study of mixtures today by separating a mixture of dyes in ink, specifically the ink from a marker pen. We're going to be following the laboratory protocol that I've already posted under assignments, and in the end we're going to answer 3 quick questions about the lab. This is a quick lab except for the development time. That's the terminology in paper chromatography. By now you should have done paper chromatography in your educational and science career, but we are going to make sure that you get exposed to it before you get out of chemistry. We're going to do paper chromatography. There are all kinds of chromatography, thin layer chromatography, gas chromatography, column chromatography, but we're going to do paper chromatography using a special chromatography made by Watton Filter Company. It's #1 grade chromatography paper. Comes in a long roll. You cut off a strip. What we're going to do is we're going to take a marker today. I will take a common Crazy Art marker. We've done it with Crayola markers, just about any kind of marker. And what I'm going to do is take this strip. We really should handle it by the edges so we don't get our oils from our hands on it. And, come on in, I'm going to, about 2 centimeters up on the paper, draw a line across the paper. Both sides so that it is uniformly saturated. And then we're going to let it dry. You can do this at home with any common marker. I'm using these because I'm going to use water as a solvent. We're going to break from the experimental protocol, which recommends alcohol. If, for example, I was doing an ink pen or a Sharpie, I would go back to the isopropanol, which you also know as rubbing alcohol. The protocol calls for a plastic cup. We're going to be a little more sophisticated, use a beaker, and rather than hang it from a pencil, we're going to hang it from a polished glass stir rod. You want to set this in there, and you don't want it touching the sides because then you'll get side effects, edge effects. And we're going to add water, just so that it touches the paper, not so that it comes up to the level of the line of ink we've drawn. And what we want is the water to be drawn up into the paper by capillary action. Brings up the whole discussion of water and hydrogen bonds and everything. And these inks are soluble in water. And they'll leave the paper and move into the water. And the more soluble they are, the faster they'll move into the water. And the less soluble they are, the less quickly they'll move into the water. And so if there are different inks with different characteristic solubilities, they will move up the paper at distinct different rates based on their solubility in the solvent. Normally we don't want evaporation occurring along the length of our chromatogram, but this is going to be a quick, simple one, so we're not going to go and cover our beaker. I'm going to add some water to the bottom of the vessel, set my chromatogram back in it, and let the water be drawn up into it. Let's see if we can get a little focus on this. And you will see it's already starting to move. Now, development of this chromatogram takes 10 or 15 minutes. So what we're going to do is stop here, and I will see you in the next video.